Have you ever thought about using acoustics to collect data? For Tech Talk 2, I'm going to discuss this technique using acoustic processing units. This technology is basically a system of audio sensors that can decipher the meaning of unknown sounds, and it has been around for quite a while in applications such as voice recognition in cell phones. While this technology is not an emerging or new technology, companies are beginning to use APUs in really new and interesting ways, changing the way that sound is used in the Internet of Things. In this case, the acoustic technology that we're going to focus on is the modified version of the APU, which is being used currently by a project called EARIT, which I'm going to talk about a little bit later on. So as some background information, the APU uses an acoustic sensor node with a microphone to capture external audio. The node digitizes the sound through a sound card, allowing for continuous recording and processing of the incoming sound. And on the bottom right-hand corner of this slide is an example of the node that is being used currently in the project EARIT. This node can send and receive data from a main server, which allows all information from different nodes to be sent to a main control server, almost like a cloud. And what's new about this particular node is that the project developed algorithms which actually run through the file and separate the desired sounds from background noises by comparing the file to different known waveforms. So how is this technology being used in a new way? Project EARIT is a research project in the city of Santander, Spain, which installed over 12,000 recording devices, APUs, around the city in various locations, mostly on street lamps. The goal of this project was to use sound in the Internet of Things to help improve residents' lives by listening to the outside environment in order to reduce traffic flow and to help emergency vehicle response times. Each of the yellow dots on the map below are sound locations, and what they found from these notes at the different locations has led to the creation of many new outdoor and indoor uses of the acoustic nodes. One particular outside application that these nodes have is that when a node heard an emergency response vehicle in the distance, and then that noise was recognized as such after being processed, the traffic lights automatically changed to green to increase the response time of the vehicle getting to the accident. The project also found that the sound nodes could accurately count cars passing by, comparing the number of cars counted by sound to numbers recorded from a camera. With this information, Project EARIT was able to give real-time traffic congestion reports as well as signs that there might be an accident. Lastly, the project also tested sending out phone notifications to users based on the sound of events occurring nearby, such as a concert or a fair. Eventually, EARIT wants to send out these notifications based on what the user likes. So if it hears a rock concert and you like rock, it would send out the information of that event specifically to you based on your interests. Here's a demonstration of using sound with an emergency response vehicle. As the vehicle moves, the screen tracks the car's position, the red dot, using sound. There are also inside applications which Project EARIT is now developing, taking the outside environment software they developed and bringing it inside. Unlike the outside applications, however, these ones are still in the making, yet what they hope the sound technology can do is to use acoustic data in the home to detect how many people are in a room and what's going on inside the room. They also want lights to turn on when the door is heard opening, windows and curtains to open and close, and even the thermostat to change based on certain sounds within the home. They're also looking into using sound for security devices and to tell if someone is safe at home. If someone cried for help, the node could transmit a distress signal and alert emergency responses right away. This video shows the audio capturing technology in action and explains the advantages of using the audio sensors over video capture.
The characteristic sound waves of a siren can be captured and automatically recognized by acoustic sensors. The smart system detects where the ambulance is coming from and can, in principle, manage traffic lights to clear the way.
Sensors have plenty of advantages. They're cost efficient and can be used for multiple purposes. And acoustic sensors don't need the line of sight. Even if we don't see the ambulance, we can still recognize it by the sound it makes.
Currently on the hype cycle, speech recognition, which is on the plateau of productivity, most closely resembles the APU technology. It's more than speech recognition, however, and can change the way we live based on environmental sounds. And while people may stray away from the idea of being recorded, researchers assure users that no personal conversations are recorded.